So there's three reds and there's five. So I
Yes.
can do like the branches like we did before.
Yeah, you can. Okay, but let me write. We have three red. So three red. We have four white. Five black. Okay, then the first ball was not replaced before the another ball. Okay. Okay, now find probability that both balls. Okay, so what is the scenario going on? They mentioned this is so important. So we have, by the way, two scenarios that they specify here. Either here they are specifying that the first ball was not replaced before the second ball. So it means you hold it at hand. Okay, this is harder than, so that sometimes they say with replacement or without replacement. This is statement exactly here. In online or some other test, they say the selection is done with replacement or without. So here, when they say not replace, it means without replacement, for sure. You know? So they may put this statement and they take away all that. It means without replacement. They may say with replacement. Without replacement is a harder scenario because when we do a replacement, then the total, when you take a ball and then you replace it, then the total never change. That is easy scenario. But that they choose now without. So without replacement, when you take a one ball out, then the total is one less. Okay? So that is harder than the previous scenario. Anyhow, so what do you do now? Find the probability that both balls were. So what's going on with the selection? Yeah, this is a probability tree. It's a tree probability. So this is the start, we say. Start. Now you are selecting two balls are drawn in succession. So you are selecting one ball and then another ball, but you keep the first ball at hand. See, not replaced. So this is a tree probability. So we say that we have a first ball. Now, because I have three categories, then this is the three categories. I have a red, white, black. But the branches represent the first selection. Now again, it may be red, white, black, red, white, black. So I need more space. I take this tree somewhere else and make it larger. Okay. So the most important is that tree should be very clear. Okay, because your answers are based on that tree. So tell me, you see what I'm doing is this is representing this first selection. First selection. Now the second selection right here, second selection, and that's it. I stop because they say I draw two balls. Finish. Okay. So what are the possible branches I'm putting now? Again, the order is this: red, white, black, red, white. Is it black by the way?
Yeah.
Black. Yeah, it's weird when they put it black. Okay, red, white, black. Hmm? Okay, so tell me, I mean, let us explore. It's the first time you see this question, but it's not hard to figure out on your own. So let us explore. Each branch, as we said before, each branch represents the probability to get the red. Now, how many in total do I have? So the total, add them up. How many in total balls I have? 12 balls. Okay, 12 balls in total. So if you are, the probability of selecting red, it would be 3 out of the 12. I mean, the probability of the red, just I'm explaining now, so it's 3 of 12. Now you can simplify that to be 1 over 4, but no need. Okay, no need. Keep it 3 over 12 to figure out that you put the numbers correct. Probability of the white, like 4 out of 12. Probability of the black is 5 out of 12. Do you agree? Those should be right here on the branches. So I have 3, 4, 5. 3 out of 12, 4 out of 12, 5 out of 12. You get it? These are the probability
Yeah.
values. No percentages given. Perfect. Now, if you put the numbers right there, you are done. Then you go to the answer, to the questions to answer them. So the tree is, if you do the tree, you are 80% done with the answer because there are marks here. Okay, your teacher would come on and see were you able to figure out these or not. You get it? So these are graded. It's not like for fun, huh? It's 80% of the answer when you do the tree properly. If your tree is wrong, your answers are wrong. Okay, perfect. So I'm
Yeah.
asking, are you able to continue? Go ahead. What do you want to continue? I mean, you want to look right here. What's going on? They selected the first ball. Now be careful. When I select a ball from the red, the total is one less. So this is now 11 from the red cube, right? It's 11 everywhere. It's 11 everywhere. This is what is good that to know that when you are selecting without replacement, because you're not replacing. So when you jump to the second selection, the total is one less for all. Finish. Is it clear?
Yeah.
Okay, now the trick is, let me see if you are able to tell the trick now. Okay, let's see. 11. So without replacement, yeah, go ahead. Can you write the numbers, the numerator? So be careful.
With
When
not
I
the same
choose,
numbers.
okay, so what do you want to write here? How much?
I'm guessing it's not 3.
Yeah, for sure it's not 3, because when I am at that level, it means, I mean, this is what we are, this is the understanding. At this branch, it means I selected one red, but when I jump to this next selection, the one red is at my hand, so I have a 3 in total, so one less, so 2 red now. But be careful, for the white, right here, I'm still here, huh? For the white, I didn't touch the white are still 4, and the black are still 5. It's only the branch that you are talking about is one less. Now the total is for all one less as well. It's not hard to understand. Okay, now are you able to figure out this? So what do you write? The white,
So
only the
3.
white would be one less. So it's 4, it becomes a 3 here. But the red still the same. The black still the same. Okay. Okay, can you figure out those?
So the black would be 6.
So the black, it changes. It was 5, then the black would be 4, but the rest are the same. It meant like the red are still 3, because I didn't touch on the first selection on that level. This meant I got a 1 black, but still the red and the white not touched, and the 4 for the white. Finished. So this is 3 is 100% correct. Now answers are so easy. Find probability that both balls were same color. So I want to see in front of me the chart. Okay, so same color. Okay, you say probability same color, but be careful. We are talking about selecting 2 balls, so it means probability to be red red plus probability of white plus probability of black black. Finish. Now probability red red, it meant to be those branches red red. So what numbers do you see? You're right. So it's 3/12 times 2/11. Simply, okay? Next, white, it meant to take this and that. What you see? 4/12, 3/11. Okay, 4/12, 3/11. Plus, black, I see 5/12, 4/11. So you see, you pick your answers from the tree. Any question? Now that I would leave it for you. It's not hard to figure out. It's so easy, by the way. The total is the same at the bottom, so it's 12 times 11. How much is 12 times 11? So 12, 11. So 12,
132.
132 at the bottom. Okay, at the top, I have a 6, I have a 12, and I have a 20. Add them up. 38, okay? So it's 38/132. Now, how much in decimal? How much is this? And the perfect answer is you write in 2 ways, decimal and percentage. How much in decimal?
0.287.
287. Don't round here. You put your full answer. 287, right? So in percentage, it would be 28.7% that this happened. That is the probability. Okay. A is done. So easy. Find probability that both balls were black. I mean, so it's so naive then, because part A was, wow, many at a time, but this is one selection for same color. Both balls were black. They can choose different, but I don't know. It's easy now. Both I mean, it's a black, okay? BB, right? So the BB is exactly the last 5/12. No need to go to the tree. You come over here because you already picked them up. You picked them up, right? So it's 5/12 times 4/11. That's it. So it's 20/132. How much is it? It should be less than the rest because it should be less than part A because this is a part of. How much in percent? Or how much in
So
decimal?
in 0.15.
2.15, so it's 15%, right?
Yeah.
Okay, finish. That's it. Is it hard? It is hard if you don't understand what's going on. It's simple. Now be careful. If that question comes with replacement, so I wanna just put a note. If the question was with replacement, it's an easier scenario because what happens is that the tree, there won't be any change in your total. So I would copy the tree. And I want to change it to with replacement scenario, okay? Because you may have a question with replacement, without replacement in the same problem. Okay, so with replacement, what happens now? Okay, so I want to change what? No more 11. No more 11, okay? How much should I put? How much should I put for the total? Still the same, 12, no change. If it is with replacement, it meant you took a ball and then you're with replacement, you replace it back. So the total no change, which is easier now. Okay. Now the rest are the same. Yes. The rest are the same. Well, ask yourself, is it the same? No, because I meant it's not the same as without replacement because I took a red, but I replace it. So it's not one less. No, it's exactly the same. So this is so easy now. With replacement, it's so easy. I mean, there is no change in numbers for the red, white, black. I mean, every red should be 3/12. You should keep it. Every white should be 4/12. You should keep it. No change. You see, I wanna take away that change 4/12 here. Every black should be 5/12. Every black should be 5/12. You see, it's so easy scenario. For that reason, I mean, yeah, we don't have usually that question in the exam, usually, but it is probable. Yeah, you may have it for sure. Any question? So, so what you see as numbers pop, they're not change at all because when you do replacement, the total is the same and the ball that you took it away, you put it back, then the red won't be one less. So that should be taken. This is more attention is going on. There's more attention here. So I want to circle that this changed, that white changed, that black changed, the rest are not, and the total changed in all, yes. But in this, no change in all numbers. So this is much easier scenario. Okay, and you go on, you pick the numbers that you see.